Okay, this is conclusion part two. So same side transverse pulses video. When a transverse pulse was sent from both ends of the slinky, the pulse passed through each other. What happened is the pulses passed through each other. Okay, so on the same side transverse pulse, so here's the slinky, and here's Angel, and here's me. We sent the pulse equally on this side, so it's traveling, and then when it reaches the middle, the pulse gets, you add both of our amplitudes together and it gets that big, so it'll be about double, and then they'll continue through back to the original amplitude, but minus a little bit because of friction. Comes the pulse amplitude um, as the pulses pass through each other. Contrast data will fade. Okay, so before they were about, let's say it was 1 foot, and then when they like interfered constructively, it was, let's say, 2, and then when it was finished, it was about 1, but you got to subtract for friction again. This type of interference was constructive. Uh, Opposite side transverse pulses video. When a transverse pulse was sent from both ends of the slinky and the pulse passed through each other. Um, so basically what happened is, here's the slinky again, and Angel is going to this way, and I'm going to go this way, and they're going to come, and they're going to meet in the middle, and when they meet in the middle, it's going to appear that there's like nothing going on, if you like were to take a picture. Um, how does the pulse amplitude as a pulses? So before, let's say it has a amplitude of 1 again, this way, and there's an amplitude of 1 for Angel as well. So they come, they're 1, 1, 1, and then they meet in the middle and 0 for both because they are destructive interference. And then they go back to about 1, but again, you have to subtract for friction. This type of interference is destructive. Fixed end termination video. Contrast the amplitude of the transmitted pulse just before reflection and amplitude of the reflected pulse. So the pulse transmitted towards the fixed end is going to be 180 degrees. So it's going to come in. So here's the fixed wall, and the pulse is going to come in on this side. It's going to come in, it's going to come in, and that's going to hit, and it's going to come out on the other side. And the phase of that is 180 degrees opposite. On the free end termination video, the amplitude of the transmitted pulse, so on the free end, it's going to come up. It's going to double once it hits the free end, and then it's going to come back, back to its regular size. And back to the fixed end, the amplitude is the same. Oh, the free end, the amplitude is the same. Sorry. In the standing wave videos, I make a statement about how frequency affected the different standing waves. So only certain frequencies can make standing waves. It has to match like the length of the slinky, or it can be half or half of that. And then, so the more frequency, the higher the frequency, the smaller the wavelength is going to be. And then describe how standing waves are formed. So when you shake the rope, or you shake the slinky, and it goes down the other side, and it starts coming back, you're going to get constructive and destructive interference at different points throughout the thing. And it's formed by wavelengths matching up with the boundary. And it's also resonance. Overall, what did you think of the Wave Properties Lab? It was useful to see in person rather than just talk about it theoretically. Was it a worthwhile learning experience? Developed a better sense. You could kind of understand what was going on when a boat was in the water, going through and then having the wake behind it. And there helps you understand like what's going on with noise canceling headphones because the sound waves coming in. It puts destructive interference and it makes it quiet.